Yes, hello everyone. Good evening. So I think I'm audible, right? So we'll start today's session. I think I'm audible, right? Yes. So this is lecture number 2 of analytical geometry. So if you haven't watched the previous video on analytical geometry, lecture number 1, so please go through that video and come back to this video, right? Because that video is very elementary and basic video for the upcoming videos. So in the previous class, what we did is we have started what is meant by direction cosines and direction ratios, right? So we have defined what is meant by direction cosine. So we have a line, draw a line that is parallel to that line and passing through origin. That line makes an angle alpha, beta, gamma with x, y, z axis respectively. Cosine of these angles is called direction cosines, right? We will denote that by L comma M comma N. L is cos alpha, M is cos beta, N is cos gamma, right? After that, we have seen some note. Note 1 is what note 1 says is L square plus M square plus N square is always equal to 1. That's what note 1 says. What note 2 says is, I'm just recalling the previous lecture. So what note 2 says is, if you have a line, right, then Li vector plus Mj vector plus Nk vector is always a unique vector along that line, right? What is Lmn? Lmn is the direction cosine of that line. And then we have seen in note 3, we have seen direction cosine for the coordinate axis. What is the direction cosine for x axis, y axis, and z axis? We have seen. After that, we have introduced what is meant by direction ratios. So any number that is proportional to direction cosine is called direction ratios. And then we see how to find direction cosine if you know direction ratio. We have to just normalize that, right? We have to divide by its magnitude. That's what we have seen. After that, we have solved some two problems. They have given two. We need to find the direction cosine of two lines. The two lines are connected by, that is, the direction cosines are connected by some relation. They will give two relation. We need to solve that, find the direction cosine of two lines, right? And then we have seen angle between the two lines if you know direction cosine. So we have seen if you know direction cosine, angle between the two lines is cos theta is equal to a1 a2 plus b1 b2 plus c1 c. Sorry, cos theta is equal to l1 l2 plus m1 m2 plus n1 n2. If you take modulus, you will get acute angle. If not, you will get obtuse angle, right? And what is the angle between the two lines? If direction ratios are known, it is cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square, right? And what is the condition for two lines to be perpendicular? Theta has to be 90. So that means cos 90 is 0. So whenever L1 L2 plus M1 M2 plus N1 N2 is 0, they are perpendicular. And for parallel, it has to be proportional. Two direction cosines has to be proportional, right? That is what we have seen. And again, we have solved two problems. Find the angle between the two lines if the direction cosines are connected by relations, right? So they will give two relation. First, we need to find the direction cosine of two lines. After we can make use of the formula angle between the two lines to find the direction cosine of lines, right? Yes. This is what we have seen in the previous class. So in this class, what we're going to do is we're going to do four more problems. That's it, right? So this class will only go for 1 hour to 1.5 hours. That's it, right? So we're going to solve four more problems that is based on parallel, perpendicular, etc. Right? So all these four problems are very, 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 very important for UPSC point of view, right? So out of these four problems, already two problems are asked in IFOS, but these four problems haven't asked in UPSC yet, right? So if they are deciding to ask question from this topic, these four are the sure shot questions, right? So you have to understand these four problems, very, very easy problems. I think this four problem itself will go for 1 hour to 1.5 hours, right? Uh, After this four problems, we'll wind off this video and we'll continue the next class. This is what we're going to do now, right? Okay. So we'll start in the previous class we have solved four problems. So we'll start with fifth problem. So 5, 6, 7, 8 we're going to do, right? So this question seems to be very easy for you, but there is one check here, right? There is one check here. So please understand this question and listen this very carefully, right? There is one twist here in this question. Okay. So problem 5 is show that the lines whose direction cosines are given by, that is the direction cosines are connected by Just a minute. Okay. So they have given the two lines whose direction cosines are connected by these relations, right? So this is somewhat similar to the previous problem we have did, right? But there is one twist. Okay. Show that the lines whose direction cosines are given by L plus M plus N is equal to 0 and 2mn plus 3ln minus 5lm is equal to 0 are at right angles. The same problem, similar problem we had already done, but this is slightly different, right? So they have given the direction cosine of two lines. They have been given explicitly that direction cosines are connected by these two relations. We need to solve these two equations to find the direction cosines of both the lines. After that, we can find angle between them. If the angle is 90 degrees, that is, if L1, L2 plus M1, M2 plus N1, N2 is 0, then we can say it is right angle. This is what we did in previous class, right? Okay. So what they have given is, we have two lines, right? So we have two lines. So we have one first line and we have second line. So this has some direction cosine L comma M comma N and this has the direction cosine L comma M comma N. They haven't given directly, but this L, M, N are connected by these two relations. That is, if you add L plus M plus N, it will give you 0. And if you make this operation, again, that L comma M comma N will give you 0. Right? So this is, we will do as previous problem. Right? So very important problem. There is one twist here, right? Yes. So we have L plus M plus N is equal to 0, right? Call this as equation number 1. And we have 2 times Mn plus 3 times Ln minus 5 times Lm is equal to 0. Call this as equation number 2, right? Usually what we will do, we will write L in terms of Mn and we will substitute back here, right? We will do that same process. So from 1 we have L is equal to minus M minus N. Substitute back into, so what is 2? So 2 is 2 times Mn plus 3 times Ln minus 5 times Lm is equal to 0. So instead of L, I'm going to substitute minus M minus N, right? As of now, this is similar to the previous problems, right? Okay. So we have this to be equal to 2 times Mn. So 2 times Mn minus 3 times Mn minus 3 times N square. And here we have plus 5M square plus 5 times Mn is equal to 0, right? So we have 5M square and 2m minus 3n 5m. So we have 2m minus 1 plus 4. So it will be 4 times mn minus 3 times n square is equal to 0. Right? So what you will do usually, you will factorize this. But here you cannot able to factorize with the help of integers. For example, here you can see sum is 4. Sum is 4. Product is minus 15. Sum is 4. Product is minus 15. So it is not possible for you to find two integer solutions. That is, you want to multiply two integer to get sum as 4 and product as minus 15 integers, right? If this is not possible, you have to go for some other way. For all four problems in the previous class, you can easily able to factorize that, right? You will get some integer. For example, 2, 3, 3 minus 2, anything. But here you cannot find two integer such that whose sum is 4 and product is minus 15. So if this happens, you need to follow this method. You need to follow this method that I'm going to teach now. Very important method. Able to follow, you can easily follow, right? You cannot find two integers such that the sum is 4 and product is minus 15. You need to go for some other method, right? Yes. Now what I'm going to do is, I'm going to divide by n square, right? Divide by n square. So this will be 5m square by n square plus 4 times mn by n square minus 3n square by n square is equal to 0. You can also divide by m square also, but I am dividing by n square, right? So this is same as 5 times m by n whole square 4 times m by n minus 3 is equal to 0. Right? Now, can we visualize this as a quadratic equation in m by n? Can you visualize this as a quadratic equation in m by n? Actually, I don't know Hindi. Sorry. Uh, can you visualize this as a quadratic in m by n? Right. So just recall what we have come across in schools, right? So what is quadratic equation? We have ax square plus bx plus c is equal to 0. This is quadratic in x. Quadratic in x. If alpha and beta are the roots, we will have two roots, right? We will have two roots for quadratic equation. Real and distinct, or it can be equal, or it can be complex roots. Yes or no? For quadratic equation, we will have two roots. Either two roots can be real and distinct, or real and equal, or no real roots. That is two imaginary roots. These are the three possible cases, right? If alpha and beta are the root, you would have come across what is the relation between the roots and coefficient. 9th standard level max. What is the relation between the coefficients ABC and roots? AEC, right? Sum of roots. Sum of roots will be equal to minus B by A. Product of roots is equal to C by A. Can you able to recall this which you have studied in school level? Sum of roots is minus B by A. Product of roots is C by A. Right? This is sum of roots, product of roots, right? We will write SOR, POR in schools. Sum of roots. This is product of roots. Right? You just recall this you are did in school level. Right? Now here we can see this is a quadratic in m by n. Right? If it is quadratic in x means this will follow. But here we have quadratic in m by n. What is the equation we have? 5 times m by n, 5 times m by n whole square plus 4 times m by n plus 4 times m by n minus 3 is equal to 0, right? Which is a which is a quadratic equation, which is a quadratic equation in m by n. Very important. If it is in x means this will follow. This is in m by n. So let m1 by n1 and m2 by n2 be two roots. Very important, right? This is how you have to assume the roots. If it is x square, x constant, alpha and beta. But if it is in m by n, assume that two roots to instead of alpha beta, you assume that roots are m1 by n1 is first root, m2 by n2 is second root. Here we have alpha beta. If it is in x, here it is quadratic in m by n. So we will have two roots, m1 by n1, m2 by n2. We are two roots. Now we know that what is product of roots? What is product of roots? Product of roots is C by A, right? So we will only use this product of roots, right? We will not use sum of roots in all these problems. Now what is product of roots? This is one root, this is second root. So we have m1 by n1 into m2 by n2 is equal to C by A. So this is our A, right? So this is our A, this is our B, this is our C, right? A, B, and C. Because this is quadratic in m by n, ax square plus bx plus c. Instead of x, we have m by n. So c by a. So what is c by a? So c is minus 3 divided by a is 5. Right? So we have m1 m2 divided by n1 n2 is equal to minus 3 by y. This is same as m1 by m2 divided by minus 3 is same as n1 by n2 is divided by minus. Just cross multiply this and this, right? You bring minus 3 here, you bring n1 n2 to that side. Is it clear up to now? Right? Call this as equation number 1. Or we have already done 1. Okay, call this as equation number A. right? So what we did is, if it is not factorizable in integers, you just form a quadratic equation in m by n. If you are dividing by m square, you will have a quadratic equation in n by m. No problem, you get the same answer only, right? Here I am dividing by n square, so we have a quadratic in m by n. If you are dividing by m square, this will be 1. This will be n by m whole square. This will be n by m. So you have quadratic in n by m. Not at all a problem. You can do that also. Right? Okay. Now, first what I have did is, I have written L in terms of mn. Right? L in terms of mn. Now, what I'm going to do is, I'm going to write n in terms of lm. And then I'm going to substitute back here. I'll explain more in detail, right, after these steps. Now, call this as equation number A, right? Now, again, you have to continue the process. So, we have from 1, what is, we know from 1, L plus M plus N is 0. This is what our first relation, right? Yes. First, here we have written L in terms of Mn. Now, you always do like this, right? Now you write n in terms of lm. Follow the same in exam point of view also. First, if you want, if it is not factorized in integers, first write l in terms of mn and n in terms of nl. You follow this, right? Now from 2, what we have? So from 2, what we have? 2mn plus 3 times ln minus 5 times lm is equal to 0. Now again you substitute n to be minus L minus m. Again you substitute n to be minus L minus m. Right? Okay. So what we will have? So 2 times m into, so n is minus L minus m, 3 times, sorry, plus 3L, n is minus L minus m, minus 5LM is equal to 0. So we have minus 2 times ml minus 2 times m square minus 3 times L square minus 3 times Lm minus 5 times Lm is equal to 0. So we have minus 2m square minus 3L square minus 3 minus 5 is minus 8, minus 8 minus 2 is minus 10. So minus 10 times minus 10 ml is equal to 0, right? Minus 10 2m square, yes. Now we'll multiply it out by minus, so we will have 2m square plus 10 times ml plus 3 times L square is equal to 0. Let us divide by L square, right? You can also divide by m square also, no problem. I am dividing by L square. So we divide by L square, we will have 2m square by L square, 10 ml by L square plus 3 L square by L square is equal to 0. So we have 2 times m by L whole square, 10 times m by L. See, again, this cannot be factorized. That is only we are doing like this. Plus 3 is equal to 0, which is a quadratic in m by L, which is a quadratic in m by L, right? So let m1 by L1 and m2 by L2 be two roots. So let m1 by L1 and m2 by L2 be two roots. Right? Be two roots. So again, what about product of roots? So product of roots is LSPOR, right? So product of roots is m1 by L1 into m2 by L2 is equal to C by A. C by A. So we have m1 m2 divided by L1 L2 C by A. So C is 3, A is 2. So we have 3 by 2. So we have m1 by m2 divided by 3 is equal to L1 L2 divided by 2. Call this as P. Right? Now you need to connect A and B. So from B we have L1 by L2 by 2 is equal to M1 by M2 by 3. Right? Now from A we have M1 by M2 by 3 is minus N1 N2 by 5. This is N1 N2 divided by minus 5. So I'm just connecting A and B. Is it clear? connecting A and B. This is why we have done like this. So you can see from here we have L1 L2 by 2 is equal to M1 M2 by 3. We will always write L M N in that order. So L1 L2 by 2 is M1 M2 by 3, and from here we know M1 M2 by, you just take minus to this side. So M1 M2 by 3 is N1 N2 by minus 5, right? So that means this L1 L2 M1 M2 N1 N2 are proportional to these three numbers. Let us say it is equal to some k. Let's say it is equal to some k. So that means L1 L2 is equal to 2k, M1 M2 is equal to 3k, N1 N2 is equal to minus 5k. Right? Both are equal. Sorry, all three are equal. Let us say it is equal to some k. Now, what happens if I add L1 L2 plus M1 M2 plus N1 N2? What happens if I add this? So we will have 2k plus 3k minus 5k, which is 0. That means what? They are perpendicular. Because L1 L2 plus M1 M2 plus N1 N2 is 0. So therefore, they are at right angles. Is it clear? Very easy problem. So first, you always remember two steps. First is write L in terms of Mn. You will have one quadratic in M by N or N by M, whatever you can. And again, you write N in terms of Lm, right? That is Ln. Remember this. L in terms of something, N in terms of something, right? So again, you will have one quadratic in M by L or L by M, depending upon what you are dividing. So again, you make use of this. So you just have to connect A and B to get the relation between L1, L2, M1, M2 and N1, N2. Is it clear? See, this problem understanding is very important. Then only you can able to follow next two problems. We can move on to next problems, right? I think you don't want to repeat. So if it is not factorized with integers, divide by n square or m square, whatever you wish. You will have quadratic in m by m if you divide by n square. If you divide by m square, you will have quadratic in n by m, right? Okay. So we'll move on to next problem. Very, very, very important problem. Very, very important problem. Prove that the straight lines whose direction cosines are given by the relation AL plus BM plus CN is equal to 0 and FMN plus GNL plus HLM is equal to 0 are perpendicular if this happens and parallel if this happens. That is, the direction cosines are connected by this relation. So apart from LMN, we have this ABC also. Yes or no? Usually we have relations between L, M, N only, right? Yes or no? For all the problems you will see, the relations will only have the terms L, M, N. So L, M, N, L, M, N. All you can see will have something in terms of L, M, N. But here we have some coefficients that are multiplied along with L, M, N. What are those? A, B, C and F, G, H, right? If this ABC is not there and FGH is not there, we will go for usual method. But depending upon this ABC and FGH value, these two will be perpendicular if this happens. That is F by A plus G by B plus H by C is 0. And these two will be parallel if root AF plus or minus root BG plus or minus root CH is 0. Very, very important problem. See, these two will be perpendicular if this happens. We need to prove, and these two lines will be parallel if this happens, right? Very simple. Usually we will have only LMN in these relations, but we have ABC and FGH. So depending upon this ABC and FGH, if these two happens, then this will be parallel or perpendicular, right? So we will consider the first, we will prove that these two lines are perpendicular if this happens, that is F by A plus G by B plus H by C is 0, right? Okay, so first we will prove this. Okay, so again we will go for the same method, right? We will go for same method. We will go for same method, that is the previous method. L1 L2 plus M1 M2 plus N1 N2 is equal to, we need to prove this will be 0 if this happens. Okay, so we have first is AL plus BM plus CN is equal to 0. Call this as 1. Usually what we will do, we will write L in terms of Mn. We will do the same procedure here. So we have AL is equal to minus BM minus Cn. So we have L is equal to minus B by AM minus C by A into N, right? I'm just dividing by A. So we will substitute L in this. So what is 2? So 2 is F times Mn plus G times NL plus H times Lm is equal to 0. We will replace L to be this. So F times Mn plus Gn L. So L is minus Bm by A minus Cn by A plus Hm into L, so minus Bm by A minus Cn by A equal to 0, right? Now what we will do is we will just take LCM with A. LCM with A. So multiply this A here. So we will have AF into Mn, and for that we will have whole divided by A. Take that A here. So the entire A in the denominator will be vanished, right? Just taking LCM. So we will have A into this plus Gn into minus Bm minus Cn, Hm into minus Bm minus Cn is equal to 0. Right? So we will have whole divided by A, take that A to that side. It will be 0. Okay, so we will have AF into Mn. So multiply this, we will have minus BG Mn minus GC n square minus BH m square minus CH Mn is equal to 0. Right? So we have n square, m square and this. So we'll collect all this. So we will have minus GC n square, right? Or we will write m square first. You can write anything, right? So we will have minus BH m square minus BH m square. And if I take Mn outside, if I take Mn outside, here we have AF, here we will have minus BG, here we will have minus CH into Mn minus GC n square is equal to 0. See, here you will always have m square, n square, mn term. You always remember that, right? Whenever you are writing L in terms of Mn, here you will always get m square term, n square term, mn term, right? Okay. Now we will let us take minus outside, right? Let us take minus outside and take this as positive. So we will have BH m square, BH m square. This will be minus because this is plus here. AF minus BG minus CF. AF minus BG minus CH into Mn. This will be plus now. GC n square. Now we will divide by n square, or you can also divide by m square also. So this will be BH m by n whole square, right? So we divide by n square, we will have m square by n square, which is m by n whole square, minus AF minus BG minus CH. If we divide by n square, we will have m by n. This will be plus GC is equal to 0, which is quadratic in m by n. Which is quadratic in m by n, right? Okay, so what about the roots? So let us take, let m1, m2, sorry, m1 by n1, m2 by n2 be two roots, right? Let m1 by n1 and m2 by n2 be two roots, right? It's good evening, Bargat. Okay. So, what about product of roots? What about product of roots? So, m1 by n1 into m2 by n2 is equal to c by a, right? Is equal to c by a. Now, what is ABC here? So, this is our A, and this whole term is our B, and this whole term is our C. So, C by A. So, C by A will be, so we have M1, M2 divided by N1, N2, C by A. So, GC divided by BH, right? GC divided by BH. Okay, so I can write this as M1 M2 by N1 N2 is equal to, I can write this as G by H divided by B by C. Both are same, right? G by H divided by B by C. Both are same only, right? Because I'm trying to bring this pattern. By G by B. Okay, let us write like this. G by B, H by C. Both are same only, right? G by B, C by H. So GC by HB. Same only, right? Because I'm trying to bring in this pattern. G by B, H by C, F by A. This I can write this as M1, M2 divided by G by B, N1, N2 divided by H by C. So call this as equation number E. This is same as the previous problem, right? So instead of numbers, we have this ABC and GH, FGH, that terms. Super, right? So first we have written L in terms of M and we have got the first relation. Now what we will do? We will write N in terms of LM. We will do the same procedure now. So from one we have, L plus, sorry, from one we have AL plus BM, AL plus BM plus CN is equal to 0. So we will write L in terms of MN. Now we will write N in terms of LM. So we have Cn is equal to minus AL minus BM. So we have N is equal to minus AL by C minus BM by C. Now substitute back in 2. So what is 2? So 2 is FMN plus G times NL plus H times LM is equal to 0. So now we'll replace N now. So we have FM into N. So N is minus AL by C minus BM by C plus GL into N minus AL by C minus BM by C plus HLM is equal to 0. Now we'll take LCM of C. So multiply C here, whole divided by C and take that C to that side. So we will have FM minus AL minus BM plus GL minus AL minus BM. This will be HCLM is equal to 0. I'm taking LCM of C here. Let us multiply this inside. So we have A minus AF LM minus BF M square minus AG L square minus BG LM plus HC LM is equal to 0. So we have minus AG L square. Let us take LM common. If we take LM common, HC minus AF minus BG LM minus BF M square is equal to 0. Now we multiply throughout by minus. So this will be AG L square minus HC minus AF minus BG LM plus BF M square is equal to 0. So we will divide by M square. So if we divide by M square, we will have AG into L by M whole square. You can see you can either divide by M square or L square also, no problem, right? So AG L by M whole square. Here we have did what we have did in this previous problem. We have did by L square only. Okay. But here we are doing by M square. Not a problem, right? We can do by L square also, right? Okay. So if we divide by M square, we will have AG L by M whole square minus HC minus AF HC minus AF minus BG into L by M plus divided by M square plus BF. BF is equal to 0. which is quadratic in L by M, which is quadratic in L by M, right? So let us take L1 M1, sorry, L1 by M1 and L2 by M2 be the two roots. So let L1 by M1 and L2 by M2 be two roots. So if it is M by L means M1 by L1, M2 by L2 be two roots. What about product of roots? Product of roots L1 by M1 into L2 by M2 is equal to C by A. So C is BF. So we have L1 L2 by M1 M2 C by A. So BF divided by AG. So this is same as L1 by L2 M1 by M2. I can write this as B by G divided by G by F, right? B by G, G by F. No. We should have B by G by B, BF by AG, L1. So here we have G by B, H by C, right? G, H. Okay, let us write like F by A, F by A, G by B. See, you can write like that also, but we need to prove like this. FGH has to be in the numerator, ABC has to be in the denominator. Both are same only, right? F by G, B by A. Yes, correct only. So that means we have L1 by L2 divided by F by A is equal to M1 by M2 G by B. Call this as B. Right? Now connect A and B, you will get the answer. For perpendicular. For perpendicular. So connecting A and B. So here we have L1 by L2 divided by F by A is same as M1 M2 divided by G by B, and from there we have M1 M2 by G by B is same as N1 N2 H by C, N1 N2 divided by H by C, right? All three are equal. Let us say it is equal to some K, right? That means we have this is equal to F by these are proportionals, right? So we have L1 L2 is equal to K times F by A. We have M1 M2 is equal to K times G by B, and we have N1 N2 is equal to K times H by C. Now for perpendicular L1 L2 plus M1 M2 plus N1 N2 has to be 0, right? So for perpendicular this is the condition. So L1 L2, so K times F by A plus K times G by B plus K times H by C has to be 0. Let's take K outside and K not equal to 0 because K is proportionality constant not equal to 0. So that means F by A plus G by B plus H by C has to be 0. This is what we need to prove, right? F by A plus G by B plus H by C is 0. Is it clear? So that means these two will be perpendicular if F by A plus G by B plus H by C is 0, right? We will have K into something. So K is not equal to 0. That means F by A plus G by B plus H by C is equal to 0 since K not equal to 0. Now we need to prove for parallel part, right? We need to prove for parallel part. Is it clear up to now? See, for parallel part, how we will do? For parallel part, L1 by L2, okay, just think about it, right? I'll give you 1 minute or 2 minutes. how we can prove that these two will be very interesting point of discussion now. How you can prove that these two will be parallel if this happens? Very, very interesting. Let's just think about it. Yes, L1 has to be L2. That is the condition for parallel, right? L1 has to be L2 equal to L2, M1 is equal to M2, N1 is equal to N2. But how we will connect that here? See, very interesting, very simple. We have we have a quadratic equation here, right? We have a quadratic equation. Yes or no? We have a quadratic equation, right? We have a quadratic equation. We have two quadratic equations, right? That is, when we are solving the first, we have got one equation. When we are solving second, we have got one equations, right? See, can you connect between the roots? Can you connect between the roots? Can you connect between the roots? See, what happens if these two roots are same? What happens if these two roots are same? We will have the condition for parallel, yes or no? L1 by M1 is equal to L2 by N2. You will have the condition for parallel, yes or no? L1 by N1 is equal to N2 by N2. So if these roots turns out to be equal roots, then that will be parallel. What is the condition for two roots to be equal for a quadratic equation? What is the condition for roots to be equal for a quadratic equation? Discriminant has to be 0. That is, b square minus 4ac has to be 0. Yes or no? Very simple. We will have quadratic formula minus b plus or minus root of b square minus 4ac by 2a. If that b square minus 4ac term is 0, we will have equal roots. Right? Very simple. So, let us take one equation is enough. Right? You can either take this quadratic equation in m by n, or you can take this quadratic equation in L by m. You can take one enough. One is enough, right? Let us make one common. Let us do one common procedure. Let us take this L by m. Let us take quadratic equation from L by m, right? Let us call this as star. So from star we have ag L by m whole square minus HC minus AF minus BG L by M plus BF is equal to 0. Plus BF is equal to 0, right? So we have L1 by M1 and L2 by M2 be the roots, right? So for parallel, if for parallel, roots has to be same, right? It has to be equal to n. It has to be equal to L1 by L2, and has to be equal to N1 by M1 also, right? That is not a problem. That means equal roots. It should have equal roots. So for equal roots, b square minus 4ac has to be 0, right? So you need to make use this condition from now on. So if whenever you need to prove for equal, you need to make use of the condition that b square minus 4ac is equal to 0. You can take any one quadratic equation, either from L by M or in M by N, right? The video lagging? The video lagging or clear? think it is slightly lagging. Okay. Okay, so we will make use of the condition that b square minus 4ac is 0. So what is a now? This is our a. This whole term is our b. Whole term is our c. So we will make use of this condition b square minus 4ac is 0. So b square, so square it up, this will be plus hc minus af minus bg whole square minus 4 times ac. ag bf is 0. So we have hc minus af minus bg whole square is equal to 4 times abfg. Let's take the square to that side. So we will have hc minus af minus bg is equal to root of this. So root of this will be plus or minus 2 root of abfg. Right? Just take square root. So root of this will be root 4 is plus or minus 2. Root of plus or minus 2 times root of abfg. Okay. So we will have hc minus af minus bg. Okay. ab hg af bg. Okay. So what we'll do is let us keep this term. Let's take this two term that side. We will have hc is equal to af plus bg plus or minus 2 times root of abfg, right? Now can I write this as root of af plus root of bg whole square plus or minus? Can I write like this? So if it is plus means a square plus b square plus 2ab formula. If it is minus means a square plus b square minus 2ab formula. Right? AFBG. Yes. Again take the square root to that side. So we will have plus or minus root HC is equal to root AF plus or minus root BG. Let us take this term to that side. You will get the required answer. So we will have root of AF plus or minus root of BG plus or minus root of HC is equal to 0. This is the condition for parallel. Root AF plus root BG, root AF plus or minus root BG plus or minus root CH is 0. Right? So this is how to prove for parallel. So if it is parallel means make use of the condition that the discriminant is 0. Discriminant is 0. Right? Okay. So we'll do one more similar problem like this. Again, next problem is also very important. This is an IFOS question. These are standard question that are asked in IFOS, right? I think it is video is lagging slightly. Okay, so we'll move on to next problem. Just correct this in upcoming video. You can see some slight lag in the video. Okay, Try to do this problem in your own, right? Very easy, similar problem. Show that the straight lines whose direction cosines are given by the relation AL plus BM plus CN is equal to 0. The first relation is same. AL plus BM plus CN is 0. And we have UL square plus BM square plus WN square. So we have UVW. UL square plus BM square plus WN square is equal to 0. Are perpendicular if this happens and parallel if this happens, right? So very similar problems. Very similar problems. Just a minute. Just a minute, right? I think the battery is off in the camera. Just a minute. Just give me 1 minute. Okay, so we'll do this problem. So you can do this problem in your own, I think, right? So show that the straight lines whose DCs are given by relation AL plus BM plus CN is equal to 0 and UL square plus BM square plus WN square is equal to 0 are perpendicular if this happens and parallel if that happens, right? So I'll do this very fast. Now let's take the first equation. AL plus BM plus Cn is equal to 0. So AL is equal to minus BM minus Cn. So L is equal to minus Bm by A minus Cn by A plus substitute this L here. So from 2 we have U times L square plus B times M square plus W times N square is equal to 0. So U into L square Bm square plus Wn square is equal to 0. Right? So expand this in A plus B whole square formula. Or we can also make use of the condition that we can take LCM of A square and so on, right? Let us take a LCM of A square. So minus Bm minus Cn whole square plus A square Bm square A square Wn square is equal to 0, right? I'm just taking A square LCM here. So A minus B whole square formula. This is same as A plus B whole square. So B square M square A square plus B square plus 2 times AB. So 2BC into Mn plus A square Bm square plus A square Wn square is equal to 0. Let us multiply this inside and let us take M square outside, right? So if I take M square outside, we have UB square plus A square B into M square. And if I take Mn outside, here we will have 2UBC, 2U, 2UBC. There is only one Mn term, I think. Yes, there is only one Mn term. And if I take n square outside, uc square, and here we will have wa square of n square is equal to 0. Right? Let us divide by n so that we will have a quadratic in m by n. Let's divide by n, divide by n square. So we will have ub square plus a square v m by n whole square, 2ubc 2ubc into m by n plus some constant term. If we divide by n square, we will have uc square plus wa square is equal to 0, which is quadratic in m by n, which is quadratic in m by n. So let the roots be m1 by n1, m2 by n2. Now what about product of roots? m1 by n1 into m2 by n2. So product of roots is c by a. So c is uc square plus wa square divided by a, ub square plus b into a square. So we have m1 m2 divided by uc square plus wa square, n1 n2 divided by ub square plus ba square. Call this as equation number a. Now what we will do, we will write n in terms of nl. So from 1 we have al plus bm plus cn is equal to 0. So we have cn is equal to minus al minus bm. This is how you have to do in exam very fast. So n is equal to minus al by c minus bm by c. So from 2 we have what is 2? 2 is ul square plus bm square plus wn square is 0, right? ul square bm square wn square. So ul square plus bm square plus w times so n square. So n square will be minus al by c minus bm by c whole square is equal to 0. Let us take c square here. So c square ul square c square bm square plus w into a plus b whole square formula. A square l square plus b square m square plus 2ab lm is equal to 0. Let's take l square here. So if we take l square common, we will have c square u, and here we will have wa square, right? L square c square u wa square, and if we take lm common, we will have 2abw into lm, and let us take m square common now. So we will have c square v plus wb square m square is equal to 0. Let us divide by m square. Let's divide by m square. So we will have c square u plus wa square l by m whole square 2abw l by m plus c square v plus wb square is equal to 0, which is quadratic in l by m. And the same story, right? So let the roots be, what is product of roots? L1 by m1 into L2 by m2 is equal to c by a. So c is c square v plus wb square divided by c square u plus wa square. So we will have L1 L2 divided by c square b plus wb square is equal to m1 m2 divided by c square u plus wa square. Let us connect a and b. So this is a, this is b. Now connect A and B. You always start with B. So we have L1 L2 divided by C square B plus WB square is equal to M1 M2 divided by C square U W C square U W A square C square U W A square C square U W A square, and from A we have M1 M2 divided by C square U W A square, same only. So UB square B A square. Let us say it is equal to some K, and let us equate every term to be equal to K. So we have L1 L2 to be C square V plus WB square into K, and M1 M2 to be C square U plus WA square into K, N1 N2 is equal to UB square plus BA square into K. Now add it up, L1 L2 plus M1 M2 for perpendicular. So for perpendicular, L1 L2 plus M1 M2 plus N1 N2 has to be 0. Take K outside, add it up. So we will have C square V plus WB square, C square U plus WA square plus UB square plus BA square is equal to 0. This K not equal to 0, this has to be 0. Now if I take A square outside, we will have B plus W. Now if I take B square outside, we will have U plus W. If I take C square outside, we will have U plus B equal to 0. This is what we need to prove, right? A square B plus W, B square U plus W, C square U plus B is equal to 0. This is what the condition for perpendicular. Now similarly for parallel, okay, so for parallel, let us take any one of the quadratic equation. You always take this equation L by M. So let us call this as star. So from star we have C square U plus WA square. C square U plus WA square L by M. C square U WA square L by M. 2ABW. 2ABW L by M. C square B WB square. C square B WB square is equal to 0. Now again for parallel, same condition, right? So for parallel, B square minus 4AC has to be 0. Same condition, L1 by M1, L2 by M2 are the roots. Therefore, L1 by M1 is equal to L2 by M2. So what is B? This is our B. So 2ABW whole square minus 4 times AC. C square U plus WA square. C square B plus WB square is equal to 0. Let's solve this. So it will be 4 A square B square W square minus 4 UC square minus 4 WA square. Oh, okay, just a minute. Let's keep this minus 4 as it is. Let's multiply these two terms now. So C power 4 UV C square UWB square WC square A square B W square A square B square is equal to 0. Now if I multiply this 4 inside, we will have 4A square B square W square minus 4 C power 4 UV minus 4 C square UWB square minus 4w c square a square b minus 4w square a square b square is equal to 0. So these two terms will get cancelled. Let us take minus outside. Let us take minus 4 outside also. If we take minus 4 outside, we will have c square uw b square p power 4 uv plus w c square a square b is equal to 0. We should have a square by u, b square by b. Okay, we should only have a square here. That means a square by u. Okay, divide by ubw. Divide by ubw. So uw will get cancelled. A square u, b square v. Yes, we have got the answer. I think we can also take c square also common, right? C square, c square. Here we will have c power 4. We will have 1 c square here. Now divide by ubw. So uw will get cancelled. So we will have b square by v. And if I divide by uvw, we will have c square divided by uv will get cancelled. We will have w. And if I divide by uvw, u will be there. This is what the condition for parallel, right? Is it clear? See, these two problems are very important. These problems are very important. These two problems are already asked in IFOS but not in IAS, right? If they are deciding to ask in direction cosines and direction ratios, these two are the sure shot problems, right? Okay, so we will do the last problem and then we will wind up. Okay, if a variable line in a two adjacent position has direction cosine LMN and L plus del L, M plus del M, N plus del N, show that the smallest angle del theta between the two positions is given by del theta whole square is equal to del L whole square plus del M whole square plus del N whole square. It's very simple, very easy problem. So we have two lines, right? We have two lines. This L1, this L2. This has direction cosine L comma M comma N. This has direction cosine L plus del L, M plus del M, N plus del N. The first line has direction cosine L comma M comma N, and second line has direction cosine L plus del L, M plus del M, and del theta is the smallest angle between the two lines. If a variable line in two adjacent position as direction cosine LMN and L plus del L, M plus del N, N sorry, yes, L plus, yes. Show that the small angle del theta, the del theta has to be very small. Del theta has to be very small. Show that the small angle del theta between the two positions, we need to show this small angle is given by del theta whole square is equal to del L whole square, del M whole square, del N whole square. Very simple problem. Okay. So see, the first line has direction cosine of the first line is L comma M comma N. So we know L square plus M square plus N square is always equal to 1. This is very simple fact. And second line has direction cosine. So direction cosine of L2, it is L plus del L, M plus del M, N plus del N. So if I square it up and add it, again it will be equal to 1 only, right? So we will have, so L plus del L whole square, m plus del m whole square n plus del n whole square is always equal to 1. You know, right? If L, M, N are direction cosine, L square plus M square plus N square is always equal to 1. So expand in A plus B whole square formula. So A square plus 2 times A into B plus B square. Right? See, del L is same one term. Don't consider del as one term, L as another term. So it will be del L is one term. Okay. So A square plus 2 times L del L plus B square plus again square root of this M square plus 2 times M into delta M plus delta M whole square, again square root of this N square plus 2 times N into delta N whole square is equal to 1. Now I can write this as uh, let us combine this. Let us combine this L square M square plus N square. Right? Let us combine these terms. L square plus M square plus N square, and let us take 2 common in these terms. Let's take 2 common in these terms. So if I take 2 common here, we will have L into delta L, M into delta M, N into delta N, and let us write the remaining terms as it is. Delta L whole square, delta M whole square, delta N whole square is equal to 1. This value is 1, right? So this value and this value will get cancelled because L square plus M square plus N square is 1. So 1 and 1 will get cancelled. So we have, uh, okay. So that means we have the value of delta L whole square plus delta M whole square plus delta N whole square is minus 2 times L into delta L, M into delta M, N into delta N, right? All this as equation number 1. Right? We have found some relations between, we have something arrived, right? Let's call this as 1. Now here del theta is the angle between two lines, right? So what is angle between two lines? If DCs are known, it is cos theta is equal to, so instead of theta, we will have del theta. Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. So here L, this is L into L plus del L, because direction question of first line is LMN, L plus del L, M plus del N, L1 L2 M1 M2 plus N1 N2 plus M into M plus del L, N into N plus del N. So we will have this is equal to, so we will have this to be L square plus M square plus N square, L square M square N square, and this will be L delta L M, this M delta M N delta N, right? See, I'm just taking L square M square N square collecting as one term. So this will be 1 plus L delta L M delta M N delta N. Now we have cos del theta, right? See, what is the expansion of cos x? What is the expansion of cos x? What is the expansion of cos x? Expansion of cos x is 1 minus x square by 2 plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on, right? Now if x is very very small, for small values of x, for small value of x, this cos x is approximated to 1 minus x square by 2. That's it. If x is very small, then cos x is approximated to 1 minus x square by 2, right? 1 minus x square by 2 factorial. This is very simple again. If x is very small, then cos x approximated to this. Now here, del theta is very small, right? Del theta is small angle. So for small del theta, this is same as 1 minus, this is same as 1 minus x square by 2. Is it clear? The expansion of cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. For small values of x, this is approximated to 1 minus x square by 2. So this is equal to again 1 plus L delta L, M delta M, N delta N. So again these two will get cancelled. So we have minus del theta whole square is equal to 2 times L del L, M del M, N del N. We have already found these values, right? Okay. So we already know this value, right? L del L. Let us take this. Let us bring this minus 2 here. So we have L del L to be this is equal to 2 times this is minus 1 by 2. See, minus 1 by 2 del L whole square del M whole square del N whole square. Right? This is what we have already found. So here we have minus del theta whole square. 2 will get cancelled. Minus minus will get cancelled. So we have del theta whole square is equal to del L whole square del M whole square del N whole square. This is what we need to prove. Right? This is by 1. So by 1, L del L plus M del M plus N del N is minus of this term. So minus of this term, 2 will get cancelled, minus minus will get cancelled. So this is how to prove this, right? So if del theta is very small, then the angle relation between this del theta and this LM and del M del N del N is this, right? Okay. So in this class, what we did is we have solved 4 problems. That is based on again DCs and angles. So the next class we will be starting again we will be continuing DC and DR only. Maybe next 2 class in another 2 class I'll be completing DC and DR. That is in lecture number 4. I'll be completing DC and DR. After we will start planes, right? So all these are very important problem. Just practice these problems. So we'll see in the next class, right? Thank you. All this.